All right, hey guys, welcome back. This is part two of the video. Welcome back to your online chemistry. We're doing these classes online because we don't want anybody to fall behind in regards to this corona prevention isolation strategy that the world is now doing. So this is your online class, and we're doing nuclear chemistry. More specifically, we're doing the radioactive particles. All right, so in the last video, we talked about four different particles. That was alpha, beta, gamma, and then the positron, which is the opposite of beta, which is basically a beta or an electron, either a negative charge, or in the case of the positron, the positive charge. All right, so we're going to add some things onto there. So everybody remembers what we learned about isotopes. And isotopes are the same element, but they have different masses because the number of neutrons change. Remember, if we change the number of protons, then we're talking about a whole nother element altogether. All right, so three isotopes that you need to know that we're going to add to this list are a version of hydrogen. So the first one is hydrogen with no neutrons. This is a zero with zero neutron. So hydrogen with a zero neutron looks like this. You got the hydrogen with the H. The 1 is the atomic number, and because there's no neutrons, 1 plus 0 equals 1 again. And we call this one protium. All right, the second one is hydrogen with 1 neutron. So we have the proton from the hydrogen and the 1 neutron. 1 plus 1 equals 2. Do is 2 in Latin, I guess. And then the third one is tritium. Tritium, I don't know how you say that. I say tritium. You say it however you see fit. But again, this is a hydrogen now with 2 neutrons. So we have the 1 proton from the hydrogen, atomic number 1, with the 2 neutrons. 1 plus 2 equals 3. Protium, deuterium, and tritium. All right. The last thing is a neutron, because with radioactive particles, they do lose protons and neutrons, or they combine them, or they add electrons. They do all sorts of crazy, weird things that make them so powerful. So that one is neutron. Obviously, a neutron doesn't have an atomic number because it's not an atom. So that's why you see the 0 on the bottom, and then the 1 is the mass. Obviously a neutron and a proton were the same thing, so 1 plus 0 equals 1. Okay, so that is your recap of all your stuff that you're going to need to do the next piece of this puzzle. Thanks, guys.